Professional desktop 3D printer technology is shifting to more industrial applications, which require improved quality, throughput, and minimum human intervention. The experiment has developed a digital twin by continuously monitoring the filament feed in order to bring automatic control capabilities to the process, improving reliability for long printing jobs. Now, the data visualization algorithm implementation will be described. The gray boxes represent the toolboxes needed to communicate the machine with the cloud service through the Savvy Smart Box. This will enable data retrieval to the cloud server so that the data is ready for further processing. Different color codes are used for the different blocks according to the DMA ontology defined in the DIGITbrain project. This enables to make the necessary connections of the solutions once it is implemented in the DIGITbrain platform. Finally, these pairs calculate the likelihood of defect under the classification of the printing job, as will be shown later. The experiment has three building blocks: the filament force sensing kit, secondly, the data handling infrastructure based on Savvy Smartbox and Savvy Cloud, where the communication protocols are configured, and the user interface visualization is configured as well. Live visualization of the process is possible. And finally, the DigiBrain toolkits based on DMA concept have been implemented, and it's available in the DigiBrain platform, as shown here. DigiTbrain has been identified as an opportunity to further include an IoT concept to the new electronics before and explore. The final aim is to develop a self-adjustment capability so that any process drift can be monitored. Following benefits are intended: process tool solution innovation, cost savings, time reduction, augmented market visibility, and process improvement and reliability.